I invite now morphing machines, Ranjani ma'am to kindly come and present the activities that they have been doing. So they are working on a multi-core accelerators and they are in advanced stage of proving their designs now. Please.
Thank you everybody for giving us this opportunity to make this presentation and show and summarize our progress with DLI as background. But morphing machines itself has a little bit of bigger background.
In the sense, morphing machines was born as an incubator at the Indian Institute of Science, and Professor Nandi, who is in the audience here, was the original founder of morphing machines. I very soon joined him to run this company, right from naming the company as morphing machines. That is, we wanted to, it was a dream, I would say. I wouldn't even call it vision, it was a dream to say, can machines morph themselves at runtime automatically, looking at the application needs. That's why the name morphing machines. And then we started with clean slate, completely indigenous, right from concept. Very, very fortunate to have PhD students and master students of IISc who primarily work with Professor Nandi to get the concept. Okay, it has to be a mini-core processor. What's the kind of core? How can it reconfigure itself? Because once we produce in silicon, everything is written in stone, if not sand. So that's how we started. And we very soon named our processor as Redefine. We very consciously named it as Redefine because we believe that we can redefine affines between software and hardware. So, Redefine, to be short, is a software-driven hardware which can reconfigure itself at runtime. We did a lot of research for the first 15 to 20, I would say 10 to 12 years before we got into relationship with Saffron Electronics from Paris. That gave us, even before that, we were engaged with Anurag, okay, to prove the concept, to prove what we had in mind. Saffron came as a breakthrough for us in 2015 to 2020, wherein they loved our processor and then said, okay, let's have simulation runs of the integrated modular avionics. Yes.
These are the engine makers.
Yes. So they were looking at integrated modular avionics and they were interested in this. That sort of gave us an experience to polish our processor and get to the current version of Redefine. Then came COVID, but then good things happened during COVID for us. First was SAFL, the Semiconductor Fabless Acceleration Lab, which was Government of India and ISA initiative. We probably had were the fortunate first to use free EDA tools. We were penniless. That really made us go, just take 1 foot off the ground. Then came blessings with mighty, both CTS and DLI. People have already talked the things that have happened through DLI directly. Indirectly, what it helped us is to make believe in the Indian investors. Saying, okay, there is some company called Morphing Machines from India. Is it going to be a reality? Okay, they have the backing of Government India, Government of Karnataka and India. Let's put some money. That's how we started. So from a team of students, we were single digits till about 4 years back. But now we are very proud to say that we are a team of about 60 people and spread over 3 centers, 1 in Hyderabad and 2 in Bangalore. So we have teams of RTL, DV, verification, simulation, PD, product and system software teams. One of my colleagues, Harish, is from the software system. And anybody who is interested in the live demo, we have, since we could not carry our FPGA system, we have software simulation running on his laptop. We just walk in front of his laptop or ask him to turn the laptop and your face will be detected.
No, we have a team waiting back in Bangalore to show actual actual live demo running on FPGA, but unfortunately the time is too short. But then this is software simulation. So I have already, I think, talked most of what is there in this slide, but I just want to point you to the fact that above 90% is all indigenous.
Of course, PCIe, DDR, those are the things that we are dependent on others. Others means outside India. Also, what we planned is, Redefine is a very scalable architecture. So we have a template. From the template, we can say, okay, do you want 16 cores for an edge AI, or do you want a 1024 core for a data center? Since all our modules are unit, module, and integrated tested, we spin out, I'll say on the fly, but actually not on the fly, but from a template architecture, we can choose the modules. Since it's all completely tested, we build the architecture. Turnaround time is very, very low. That is one of the key things in the way we have architected. So our focus areas are going from edge AI to data centers, but this year we are concentrating on data center because we can't really run thin, We can say it's reconfigurable over several domains, but we need to focus on one, and that is the data centers. In particular, we are looking at something called fully homomorphic encryption, where the data in encrypted form can be analyzed. The downside of it is the computations blow up to 10 to 3 to 10 to 5. So what is the kind of architecture which can do it? We believe Redefine can do it. That's what we are currently exploring. We have a huge market within India and outside India. If I can ask Professor Nandi just to say that the numbers, that will be.
Yeah, I would say okay, thank you. We noticed that typically the market size annually is about 120 million in this kind of FHE-based encryption, and we are already in conversation with 3 banks, and we are looking for a joint POC with RBI, SEBI, ICICI, and HDFC. And we also have 2 consumer data centers who have confirmed interest, that is SIFI and NextGen.
So it's not only the finance and the banking. All of us want to keep our bio data, the DNA data within ourselves, so it has huge impact on the healthcare analysis also. So the data goes as encrypted data to the analytics center. Analysis is done on encrypted data, and the results are also sent back in the encrypted way. So that's what we are looking at. I don't want to press it on you, but sorry. Okay. So as we talk today, May is the time frame where we are going to get the first test chip out. And going forward, we are planning one next version of Redefine every year with all the markets that I have just mentioned. And with DLI, I need to mention it here, we are about 50% through the journey of the whole, from design, implementation, testing, simulation to tape out. And May is the time frame we are looking at. Rolling it out on a 28 nanometer TSMC. Going forward, it will be 12 or less than 12 nanometer, probably with Samsung, that we are in talk with Samsung. So we will be fully operational sometime in 27, 28, and we want to really start getting global. Carve a niche for ourselves. GPUs are good in certain aspects, bad in certain aspects. CPUs, FPGAs, all have their market. We want Redefine also to carve a niche for itself in the global market. That's the vision we have going to 2030. So with that, I think I have much more exceeded it in the time I was allocated. Thank you.
Very good.
Thank you, friends, and thank you all the startups, thank you all the professors for doing such a great work. I really thank Jyoti, Gautam, Arjun, Sridhar,
Dr. Ranjani, Sashwat, Sunil, Vijay, Arumugam, Srinivas, Vinayak, Rakesh, Shashank, Sai, Manish, Ravi, Kiran, Pratap, and I look forward to going through the inputs that you have given.